Decomposition is the process of breaking down a high-level, complex description of a system into more manageable pieces. The goal of the decomposition process is to make common tasks simple and exceptional tasks still be possible. Right? We want to make sure that those unusual tasks are still supported by your system, but they're not our dominant concern. So there are many different ways to decompose a system, but the two most common are to decompose a system from the top down, right, going from a high-level description down to more concrete units, or to compose a system by starting at the bottom level and working our way from the bottom up to compose the system at a high level. In top-down decomposition, we'll take a high-level abstract description of what we're trying to build and successively add more and more detail to it. So if you imagine you had a system description and you broke it up into two main modules, and then you broke those modules each up into a few submodules each, and then again into classes and then individual methods and fields, right? So you're breaking up your system into more and more fine levels of granularity. So this is great because you can have an overall high-level understanding of the architecture of our system because we started from one coherent element and we broke up the system successively. But at the end, our low-level leaf nodes often end up conflicting with one another because you'll have made some decisions over here that might be a little bit different than those decisions over here, which require us to go back and add more detail. So there are both pros and cons of top-down decomposition. So let's take a look at a concrete example. So imagine we're building a game. And this game could be Mario. And we want to split this game up. We're starting from the top level and we're working our way down. So if we're building Mario with this game, we naturally are going to end up splitting this into level. And then we have some figures, like some figures that run around levels. But that's not enough, right? We can't just go and build Mario with just level and figure alone. So let's break them up further. So if we think about figures, right, we need to add the concept of Mario and the concept of an enemy. Right now, if we're thinking about the level, we need to split this up as well, right? So levels contain items, and maybe they do other things, like they play sounds. Right? But then we have other concerns we want to think about as well, right? So for a level, right, how do we add input? Where should that go? Should it go in level or should it go in Mario? I don't actually know, but Mario is the one that's moving, so let's put input here. Right? And then we want to handle collisions as well. So in this way, we've gone and taken this notion of a game and we've split it up into several different concrete elements. And if we think about it, one thing that stands out here is input. Right? So input, we've put off Mario. But remember from our prior discussion, input was actually something that happened to a level. Input flowed through the level class. Right? So this is one place where when we start top down, we can go and have our blinders on and come up with a design or a decomposition that might not match the best design in practice, right? So in this case, right, we need to go back and think about what's the best way to handle input. And that's something we would need to think about. But this is just an example of how you could take a high-level concept and break it down into more concrete elements. An alternative approach is to compose our systems from the bottom up. So when we do this, what we're doing is we're thinking about concrete low-level elements that we're building at the low level, and we're slowly going to build our system by putting them together at successively higher levels of abstraction. So this is great because it gets us building our systems early, and it helps us to focus really well on building reusable code. But it can be problematic in that once we get to high levels of abstraction, we realize that we might have made low-level implementation details up front that cause high-level inconsistencies that are challenging to overcome in the end. Here's a concrete example of bottom-up composition. So say we're designing a system and we know that we need two primary data structures, a hash set and an array list. And over time, we realize that we need more and more specialized versions of these hash sets and array lists. So we're going to add a vector and a tree set. Right, so now we have these four low-level concrete types. But we realize that there's some commonalities here. Right? So tree set and hash set are indeed both sets. And array list and vector are both instances of lists. So in this way, we've managed to bubble up. We've come up one level of abstraction on the low-level concrete types. But again, list and set are both instances of collections, so we can have a higher level layer of abstraction here as well. So in this way, we've managed to take our two initial types, hash set and array list, which we built out to be more concrete types later, and find two layers of abstraction above them. Right? So we've managed to compose this entire type hierarchy by just looking at the commonalities between the code elements that we actually have. And this is an example of how bottom-up composition can work in practice.